All right, ladies and gentlemen, we are going to talk about exponential growth today. So exponential growth, definition. Exponential function is a function that involves the expression b to the x power, where the base b is a positive number other than 1. So for an exponential function, that b can be some fraction between 0 and 1, or it will be above 1. Now for today, everything we're going to do, because it's exponential growth, b will be bigger than 1. So because we're talking about exponential growth, b will be bigger than 1. Okay, exponential growth. So let's start off by making a table so we know we can look at what's going on. So I'm going to make myself an XY table. I'm just making up values, and those are the ones I'm choosing to use. So down below here, down here in the bottom, I'm going to make this my scratch paper. So I'm looking at 2 to the negative third power. Well, 2 to the negative third power is really 1 over 2 to the third power, because remember the negative says, I don't like my party location, I want to switch. And then we take and cube it, we get 1/8. So 2 to the negative 2 power is, once again, that negative says flip it to the denominator. It wants to change its location, and then we square it, so we get 1/4. And then we have 2 to the negative 1 power, which is just a simple flip. And if you remember, anything to the 0 power is 1. 2 to the first power is 2, 2 to the second power is 4, and 2 to the third power is 8. Meaning 2 to the first is 2, 2 squared is 4, and 2 cubed is 8. All right, so now let's graph this. Okay, so let's graph what we have. At negative 3, we're at 1/8. So we're down close to the x-axis, but not quite there. And at 1/4, we're at negative 2, we're at 1/4, just a little bit more. And at negative 1, we're at a half, a little bit more. And at 0, we're at 1. And at 1, we're at 2. And at 2, we're at 4. And at 3, we're up here at 8. Okay. So the question I asked in class today, which you're not here to, weren't here to hear, is there a number I can plug in for x that's going to make this cross the x-axis right here? Am I going to cross the x-axis? Is there any x? And there's not. I can plug in any negative number I want, and the bigger the negative number, the smaller my decimal is going to get. So the closer it will get to this, but it will never cross the x-axis. And that is what an asymptote is. An asymptote is, think of it as a wall. It is a line that the graph will not cross. It's this wall. So in the case of this problem, we notice that we're going to get closer and closer to 0, but we're never going to cross it. So we put a dashed line to represent that that's our asymptote. And then I go ahead, and when I'm drawing my graphs, I just make sure that my pencil or my pen never touches the x-axis in the case of this problem. So what's my domain? Well, my domain, I can plug any number I want in for x. So my domain is all real numbers. But let's look at my range. If you notice, there is nothing down here below the asymptote, below 0. So my range is going to be that y has to be greater than 0. Not equal to, just greater than 0. My y's will all be above that axis. Okay. So on this slide, we talk about the effects of A. And I will go over that in just a second when we get here, to the fact that we have general exponential function. And the general form is a times b to the x minus h. Yes, h is back, plus k. So h and k are back. So let's talk about what they all do. A is your, what I call the initial intercept. And that would be initial y-intercept. Okay, I say initial because if h and k have a value other than 0, there's going to be a shift involved. So A is your y-intercept, but it's your initial one if there's an h and k. It also has the role of telling you which way it's drawn. Are we going to be above, or will it be below the asymptote. So will the graph be above or below the asymptote? That's what A tells us. H tells us H's role is a shift. It is our shift either left or right. And that's the only role H has. But remember, H lies to you. It pulls out opposite. Okay? K has two roles as well. It is also a shift. And if you remember, it's your shift up or down. And it is your asymptote. So K also represents the line that you will never cross. Let me change up. Let's change this problem, the first one. I'm going to make A negative. Okay? I want to make A negative, just so you can see what that graph looks like. All right, so here we go. What is A? Well, A is negative 3. What is H? H is 0, because there is no H. It's just an X up here, so H is 0. K, what is K? Well, there is no plus or minus any number over here, so K is also 0. So, remember, K is also my asymptote. So when I graph this, I'm going to put an asymptote at 0. So you're going to draw in a dashed line for me, ladies and gentlemen. Okay, draw me the dashed line. And then I'm going to put my put my pencil on my right here, which is, remember, this is my y-intercept. And I'm going to shift it. Well, am I shifting it? I'm shifting it 0 places right or left, and I'm shifting it 0 up or down, so I'm going to end up with my y-intercept right there at negative 3. Now, as I said, these are exponential growth problems, exponential growth. And so these, you will graph this such that I call this my submarine sinking or diving, because it's below. So it's my submarine diving. It's because it's below the x-axis, because it's below the asymptote, it's below the asymptote, it will be going, it's a submarine diving. Versus our other problem here. So let's do the same thing here. A is 3. H this time, though, well, it says -1, so that means H is a positive 1, and K is negative 4. So now I know that I have an asymptote at negative 4, and I have an initial y-intercept at 3. So what does that graph look like? Okay, so my asymptote's at negative 4, so I'm going to put a dashed line at negative 4. My A is positive, so I know my graph will be above the asymptote. I'm going to go to my initial y-intercept. So initially we're here at 3. But my H tells me to move 1 to the right, and my K says move down 4. 1, 2, 3, 1, 2, 3, 4. So I'm going to be right there. Now, because we're above the asymptote, we are an airplane. I call this my airplane taking off. This is my airplane graph. Okay, so remember this is an airplane taking off. All right, so I could go back and do the 2 other examples, but they're going to graph like this. One of them was a exponential growth, but the submarine diving, and the other one was an exponential growth airplane taking off. So those are your notes for today. In the homework tonight, it is a worksheet. And I expect you to, besides graphing them, you will find the domain and range for all of them, and you will graph using a point and the asymptote. So just like I did the last two graphs that I did on here, that's how you will graph all of your homework. All right, have a good day.